Hello everyone, myself Dr. Vijay Vishwakarma, and today I will teach how to run G_MM software. Basically, this video have two parts. First is the running of program and second is the analysis of data. केम विज्ञान यूट्यूब चैनल पे आपका स्वागत है। हमारी वेबसाइट भी है www.kemvigyan.com। From where you can learn too much computational chemistry, mainly docking, MD, MMPVSA, and somewhat DFT. Basically, this website is under growing phase, so somewhat a little bit data about DFT and other calculation are not uploaded, but according to time, this will be updated. So let us begin how to perform the G_MMPVSA analysis. In previous lecture, I have told how to configure, means installation of G_MMPVSA. And if you do not have idea how to configure, you must watch this video, and after that you can watch this video to how to use the G_MMPVSA software. Basically, configuring is very much important, and I am running G_MMPVSA on GrowMax version 202. So I think this is not too much old version. So let us begin how to start. First of all, go to the web browser and download the necessary file to test the software. And you can go to Rasmi Kumari. Just type G_MMPVSA and it will direct you to GitHub link of Rasmi Kumari. Just click on here. Go to the tutorial. Since here I am going to show how to calculate the different types of energy like polar, salvation energy, apolar, and binding energy between protein ligand complex. So here, first tutorial, binding energy of single protein inhibitor complex. So before running this program, you have the following files in your folder. Just click on the link for the tutorial package, that is the link, and download the necessary files. Okay, that is the files have been downloaded. So just go to your download folder. This is the file. Just copy it and paste in C drive. Okay. Now open your Ubuntu. Run Ubuntu as an administrator. And type the command cd/mnt/c/ and press enter. Now we are in the C drive directory. Just locate your file by typing ls command. So here, this is the file of our interest. tutorial.tar.gz. So first of all, we have to enter this file by typing command tar dash xbzf tutorial dot tar dot gz. Okay, so you can see here that the folder named tutorial is formed. Just press enter. You see these are the parameters file, MDP files, and these are necessary for the running of the program. So when you are going to run this program, just copy these all files and put in this folder, or just copy all these files which are input files and cut it and paste it in tutorial folder. Okay, so we can say that this is the file where your necessary MDs file are prepared by the GROMACS, and the required files is mainly .xtc file, .tpr file, .ndx file. These three files are necessary files for the calculation, and one is most important mmpbsa.mdp file. So let us go to the tutorial page. First of all, we have to set up the environment variables, either editing the bars file .bshrc file or exporting on these commands on the terminal. The calculation of three energy component are as follows. This is the first A part. This is the B part, calculation of potential energy in vacuum, polar salvation energy, and third is calculation of non-polar salvation energy. Okay, if you only want to calculate the solvent accessible surface area, then you can use this command, and if you want to calculate the solvent accessible volume, then you can use this command, that. Okay, but I am going to show here one step calculation. In one step calculation, these all parameters have been calculated for your protein ligand system or protein inhibitor system. So what is the requirement? First of all, the environment variable to set in the terminal, and second is the command, and third is pbsa.mdp file. So let us go to your folder and check. This file is here and necessary input file are here. So we can go for the execution of command. Before executing the command, we have the idea about the APBS software. Basically, this involves for the calculation of polar salvation energy. Okay, so most of the time you find the error, the segmentation fault, and within bracket core dumped. If you are getting this error, this is mainly due to that you do not have configured APBS in proper manner. Okay, this is only the fault generated by APBS program. So let us execute the command. First of all, set the environment variable, and these are the commands which I have written here. What is the necessary environment variable? First, importing the GROMACS. Okay. So just copy the command and paste it on terminal. First of all, we have to move inside the directory, that is the tutorial. Now paste your command one by one. Okay. Before starting with the commands, you also have to the super user privileges. So you have to run the command sudo su for getting the super user privileges and type your password. Just press enter and you get the super user privileges. That the color of the terminal command prompt has been changed to white. It means you have the super user privileges. Now we have to copy and paste these commands sequentially. Okay, first command. Now the second command is exporting the GMX libraries, means GROMACS libraries. Now third is exporting the MMPBSA software. Now the last one is export of APBS. Let us make clear that you have installed your APBS in user/bin ABPS. As I have told in tutorial, during the installation of G_MMPBSA software, your default location will be this. If your location will change, then you have to change this one, user/bin/APBS. Now press enter, and I think export of all three have taken successfully. So now we have to move towards the final command, and that is given on the website. Okay, so just copy this command, and this command is basically for one step calculation when all three steps will be completed. So here I am going to paste this command, but slight modification is here because I put all the necessary file within a folder. So you do not have put these dot and slash parameter. Now press the enter and select first for protein and 13 for your BEC ligand. Press enter. So finally, the ABPS is working and G_MMPBSA is running. Basically, I am processing this data on GROMACS 2018 source file. Sorry, I think this source file belongs to too old version, but doesn't mean you can process these data to up to the GROMACS 2020. Okay, so don't worry. Now I am pausing the video, and when the calculation will stop, I will show how to extract the data and how to plot the graphs. Now you can see the calculation is still running. So I'm again pausing the video, and once the calculation have done by the G_MMPBSA, I will show how to plot the graphs. Finally, the calculation ended successfully, and it also tells a quote like Gromax. So here you see, thanks for using G underscore MMPBSA. Thank you. Means without any error, we get the data. It also uh, says a quote. I always think there is something foreign about jolly phrases at breakfast. So it means that your calculation is successfully completed without any error. Now the time is to execute the results. So just go to the page, tutorial page. Now, if you want to calculate the average binding energy, so we have to take the average of all the points and datas. So you can also download a script, Python script, that is mmpbsa stat.py. So just click on this link. One second. Just click here and you get a file mm. Now download this file. Let us check whether this file is within the folder or not. So first of all, this file is not in folder. Okay, so we can download it. This is the file. Okay, so just download it. Just download it by clicking on this, right click on this and copy link and paste in terminal using wget command. So we can easily download this file. Now we can say here in tutorial folder that mmpb pbsa statics.py file is here. So now we can go to execute our command. Just go to the main page of tutorial. Okay, and copy this command and run. Control C and paste it in terminal. Before pasting it, you have to ensure that you have to previously install the Python. If you do not install the Python, you get the error. Now press the enter. Okay, so here I am also getting the error, and this is most probably due to the not due to the Python, due to the invalid syntax. So let us check how to solve it. Well, this error is mainly comes and says that no module name built in. Means Python have several modules. I tried too much commands like sudo pipstall built-ins pipstall numpy python module and etc. But nothing is working in my laptop. Like I also install sudo pipstall future, but it is not working. So to overcome this problem, because this command python mm pvsa stat.py is basically a py file running. So this is a python script. So we can perform this command using command prompt, and this is the final solution from my side. But in case if you are running on linux environment, most probably this error will not come. Okay, so what to do? First of all, open command prompt as a administrator. As I have performed, just type python and it will install python. After installing python, change your directory to tutorial in command prompt. Now again run the syntax. This is the syntax python mmpbs pbs stat.py and etc. But here it shows that import numpy as a np, because numpy is a module and it is represented as np, and it again so no module named numpy. It is just like a inbuilt error. Just we are getting in ubuntu, that is the built-in no module, built-in no module named built-in. So to overcome this problem, we can install simply here pip3 install numpy. This is working, and after typing this command, it download and install the numpy. Finally numpy successfully installed. But here the distribution error, like built-in module does not came, only the numpy error came. But this numpy error can be solved, so this is working for me. Now type the command python mmpbs stat.py and etc. It executed without any error. Now we have to go to check, because the two files is generated, summary underscore energy, this is the dat file, and full underscore energy. So to show you, I am going to delete these two files. Simply delete, and now again go to command prompt and run the same command, that is okay. So again you can see here that these two file created and without any error. So this is the final solution, because the last script is uh, the last script is python script, that is this one, and execution by also by python. So it does not issue whether you are running to get a result. So I am going to show how to saw these two results and how to draw the graph. First of all, uh, we have to open summary file, and second we have to open full energy dot tag. Okay, so in window, basically in window you can do by using excel. Just open excel. Okay, and then go to file. Now open and go to browse and browse your file like C drive, tutorial, and select here all files. Now first of all I have to show summary. Okay, Now open summary. Just check that this is delimited and press next. Check this one. I think this is fine. Tab separated. Now press to next and finish. So we have a data just like the tutorial. So you can see that. Hopefully this binding energy, van der Waal energy is minus 334. What we get the result? Just go to Excel file, minus 334.587. 587. So both results are same because the same system is taken. Now similarly, we can also open the full energy.dat file and go to the browse, open full energy, this one file, and again just scroll down. But I think here we have to select the space separated value, tab and space, so we get a better result. Okay, now this is the parameters. Here the binding energies of the binding energy data. This is a polar protein. So we have to only focus on the delta value, and these are the delta values from here. So just broaden it, and you can find that it is the delta value. Okay, so this is delta mm. Now just copy it. Oh, 1 second. Control Z. Just copy this value, this parameter. Control C, and add a new sheet. Paste it here. Okay. Now just copy this one, time slot. Okay. Now remove this, and we can draw the graph just like the in tutorial. Select both row. Now go to insert and graph chart section. Select the line. So this is the graph. Delete these grid points, and you can label your graph as per your. This is the delta E. You can add the axis title. This is the time axis. Okay, and this is the delta E mm. So in this manner you can draw the graph. Just check whether the graph is just like similar to that one or not. Okay, so this axis is taken in negative. minus 560 for, well, okay, basically here is a error when we going to delimit the data. This value mainly belongs to this section. Okay, so you can simply cut it and paste it, or you can delimit your data as per your experience. Basically, the delimiting with the space have some issue, so just try with tab separated. So this is the delta e value. Okay, and I have copied the wrong one, that is the polar complex. So you can paste it here and your graph will be changed as per the value. So now we are going to show, so sorry, I am going to show that is the graph. Just format your axis and your graph look like the as per the given in tutorial. This can be done by axes. Go to more option and scale it. That is the minimum 400. 1 second. That is the axis minimum 00 and 600 2000. Just change it. Okay, then this is 00 and 12,000 means this it is showing this axis. So just click on this axis and change the value. Minimum value is, take it from 350. Well, just take it to minus 350 and your graph just look like the graph as given in tutorial. So you can compare your graph with the tutorial graph given as given in tutorial. So in this manner, you can also draw the binding energy, delta Z polar and delta Z apolar graph along with the summary file. So this is the all about the tutorial, how to use GMM PVC software and how to obtain data from this. In this section, I get two errors, and these two errors is mainly highlighted by me. First of all, uh, the error is core dumped. First error is dumping of core. So then this type of error can be solved by executing ABPS, as I have told. Okay, and second is the no module named built-in. So this can be tackled out by using command prompt in window, as here I perform this type of activities and told in detail how to tackle this. So hope you will able to perform your calculation. Thank you for listening me. Have a nice day.